Hi everyone, welcome back. In this video, we're going to take a look at what it means for something to be a function. So functions do have an important definition, and we'll take a look at that in this video. So we've been working and talking about functions and working with functions for a while now, and you've probably talked about functions and the word function in middle school. For Algebra 1, it's important that we define what exactly a function is. So here are a couple of examples of how some students have described functions when I've asked them in the past. Sometimes some students will say a function is an equation, or another description I've heard is an equation where we can plug in something for x and we can get an output, kind of like we saw with our function machines. And these are both good descriptions of what we've seen for functions so far. Functions do have an important definition though, and I want to go over that definition in this video. So function is actually a very specific word that means that's describing a very specific relationship. So a function is a relationship between two variables. Relationship between an input variable, which we can call x, or we usually call x. One note is this is what we call the independent variable. And we'll talk a little bit more about independent and dependent in a later video. Here we're just looking at input variable, between input variable and output variable, which we usually call y. That's called our dependent variable. And again, independent, dependent, we'll talk about what these mean in another video. So now just focus on input variable, output variable. We have a relationship between two variables where, and here's the important part, each input or x value that we plug in has only one output, or y value. So here's the important part of our definition. Each input has only one output. So for functions, whenever we input a value for x, we can only get one output for that function in order for it to qualify as a function. If we plug in a value for x and we get more than one output, then what we have is not a function, unfortunately. So what I want to do is take a look at an example using a soda machine. All right, so here we have a soda machine, and we're going to use the soda machine kind of as an analogy for functions. So we have a soda machine. On the left here, we have the buttons for our soda machine, so these buttons. And then right here, we have kind of like the bottom bin where all of the cans come out of the machine. In other words, the output for the machine. So we can think of the buttons as the input into our machine or into our function, and then the cans as the output from our machine, or the output from the function. So another way to think of the soda machine is as a function machine too. So on the buttons on the right, we might have a few different options, like maybe we have a Coke option, and we have an option for Sprite. And then maybe if you want to be a little bit healthier, we have an option for water, so H2O. So we have a few different buttons that we can press. And when we press a button, we expect that soda to come out of our machine. So if we press, for example, the Coke button, then we should get a Coke can as our output. We should get a can that has Coke on it. Okay, and so every time we press a Coke button, we get a Coke can. Every time we press a Sprite button, we'll end up with a Sprite can. Every time we press a water button, we'll end up with a bottle of water or a can of water. So if this happens every time, then we have, so if this happens every time, then we have a function. Have a function. So this is true because for each input, there's only one output that's ever going to come out. Every time I press the Coke button, we'll always get a Coke can. It's never going to mess up and give me a Sprite can or a can of water. So each input has only one output associated with it. If we press for example, a Coke button, and maybe sometimes we'll get a Coke can. But also sometimes, maybe it's a little bit mixed up, sometimes we get a Sprite can. In this case, because our input of Coke can result in more than one output, so there's two different sodas that could be coming out when we press Coke, then we do not have a function. So there's more than one output associated with that one input. There's more than one can that could come out from that one button. And it's not a function, and also the soda machine isn't working correctly. I don't want to press the Coke button, like really craving a Coke, and then have a Sprite come out. So I would be maybe a little bit disappointed in that case. And here we don't have a function, so it's kind of like our machine isn't working right. Another thing to look at is sometimes you might notice on soda machines we'll have multiple buttons for the same soda. So sometimes maybe there's a soda that's more in demand. Maybe they're selling a lot of Coke from this machine, so they have two Coke buttons. And you could press either button, and either button will give you a Coke can. So here we have two Coke buttons. And if we have two Coke buttons, and each button, we have two Coke buttons. Each button always gives a Coke can. Then, kind of drifting off down to the left here, we have a function. Then it is a function. So it's okay if we have two different buttons that give us the same Coke, or the same type of can. In other words, it's okay if there are two inputs that result in the same output. We just need to watch out and make sure that for one input, there aren't two outputs. So the opposite can be true. We can have more than one Coke button and press either one and end up with a Coke. Our machine is still working properly. In other words, we still have a function in that case. Okay, so I want to take a look at identifying a function from a table and then also from a graph using this definition that we've talked about so far. All right, so here we have a table. The x variable represents the temperature in degrees Fahrenheit. The h of x, or the output, represents the number of ice creams sold on that day. So maybe you're running an ice cream stand, for example. So when it is 70 degrees outside, we sold 10 ice creams. When it's 85, it's a little bit hotter, we sold 20 ice creams. Really hot day, 100 degrees, we sold 32 ice creams. We also sold 32 when it was 95 outside. Finally, it dropped back down to 70, and we sold 15. Maybe people were still craving ice cream because the previous day was 95 degrees. So here, we might be asked, is this a function or not? So there's two things to notice here. First, one thing you might notice is that we have the same output, 32 ice creams, for two separate days. So both 100 degrees and 95 degrees, we sold the same amount of ice creams, 32 ice creams. This is okay. This is fine in terms of functions. It's okay if we have more than one input that gives us the same output. That's fine. Another thing to notice on this graph, though, is that we have 70 degrees for one day, and we also have 70 degrees down here. And most importantly, those 2 days, 70 degrees, have different outputs. So one thing to notice is for 70, in other words, x equals 70, there are two outputs associated with 70. So if I asked you, it was 70 degrees on a day, how many ice cream cones did you sell that day? There are two different ways that you could answer it. And unfortunately here, this means that we don't have a function. There are two outputs for one input. And those two outputs, as we can see, are 10 and 15. So this is what makes this table or this relationship, not a function, is we have one single input, 70 degrees, that has two possible answers or two possible outputs. So we do not have a function. However, the opposite is okay. If we have two inputs, they give us the same output. I also want to take a look at some graphs. So on the left, we have g of x. We might be asked, is this a function? What we can do is look across the graph, left and right, so looking at our different x values, and we're looking to see, let's choose an x value. Let's take a look at where the graph is. Is there only one y value associated with that x? So over here, for this x value, there's only one y value, and it's right here, whatever y value we have on our graph. And this is true no matter which x we choose. There's always only going to be one y value associated with the graph. So this we do have a function. For f of x, however, if we choose an x value, like here, let's choose maybe -1. Notice that there are two possible outputs, or two possible outputs for that single x value -1. So maybe -1 could give you a +2 or a -2. Because of this, f of x is not a function. So one single output, -1, can result in more than one single input, -1, results in more than one output, 2 or -2. This is something that we call the vertical line test. In other words, if you take a vertical line, you could also just use your pencil, put your pencil up to the graph, and if it intersects the graph more than once, if a vertical line intersects the graph more than once, then it's not a function. So here we have a vertical line up and down, and it intersects our graph twice. So we do not have a function for f of x. For g of x, you could place a vertical line anywhere on the graph and it'll only intersect it once. So we do have a function in that case. All right, so we took a look at what a definition of a function is. We described functions in terms of soda machines, and then we also looked at identifying functions from tables and from graphs.